Almost everyone wants to become an AI engineer in the year 2026, but the reality is that hardly a few of them know what it really means. Do you really need to know deep ML maths? Do you really need to read 50 research papers based on ML? Or is it just about prompting ChatGPT? Because if you open LinkedIn these days, a lot of people, after having built just a toy application, which is nothing but an LLM wrapper with some fancy prompts, claim to be an AI engineer. But let me tell you, that is not how it really is. Let me give you an example. If you go to ChatGPT or Claude and ask it that, hey, just draft an email and send it out to my manager, what will it say? It will say that I can just draft the email for you, but I can send it on your behalf. Similarly, if you ask it to find your offer letter from your Google Drive folder, it would say, hey, I don't have access to your Google Drive. That is something which you might feel pissed with, because you don't want your agent to just act as a chatbot. You want actions out of it. You want it to autonomously act on your behalf at times. And while acting, you want it to reliably act almost 100% of the times. Because an agent which does right thing only 70% of the times and fails for 30% of the times is not really an agent, it's a liability. In this video, I'll talk about what are the skills that actually matter and help you to build a reliable production-grade AI agent. Hey, my name is Vivek. I graduated in computer science from IIT BHU, and after that I worked as an SDE at Amazon for around 2.5 years. I later co-founded Programming Pathshala, which is an edtech where I have taught thousands of software engineers and helped them to upskill their career. In the past 2 to 3 years, I have seen how agentic AI applications are really built and productionized. And what are the skills that will help you move from building LLM wrappers to a robust AI system? And the things that you can avoid learning so as to not waste your time while trying to learn agentic AI engineering. I'll talk about the biggest myth first. Agentic AI is not the same as core ML researcher. An agentic AI engineer does not do the work of a core ML researcher or scientist for that matter. They do not need to know heavy linear algebra or PhD level maths. Basically, an agentic AI engineer is somebody who learns to build a useful software on top of LLM. The very process of building useful software system on top of LLMs is something which is very intensive and has some serious learning curve attached to it. I'll be very honest, I have met engineers who have had almost zero knowledge of LLM architectures, transformers, attention mechanism, deep ML theory. They never read any sort of ML research paper, but still they were able to build some really exceptional production-grade AI systems. And if you ask me why, there are two reasons. First, they were already exceptionally good software engineers. Secondly, they were very hungry to learn new things and paradigms. See, take example of things around you, like Cursor, Claude Code. What are these? These are not LLMs. These are software systems which are built on top of foundational LLMs, right? LLM for them is just a brain. But Claude Code, or for that matter Windsurf, are operating systems which are built on top of that. You can think of it in this manner. Almost every engineer watching this video would have heard or used MySQL. But before using MySQL, do you really dive deep inside the indexing internals, the buffer pools, the storage engine, the query parser? I can bet that 95% of the people, or even more I would say, do not do that. Why? Because the real engineering happens above it, where you configure connection pools, you write transactions, you do rate limiting, you protect against SQL injection, you perform replication, and all such sorts of things. Now tell me one thing, are all the engineers who treat MySQL as black box really able to do these things in best possible way? The answer is no. Only a few who really have gained expertise in doing these things. Same applies at the level of LLMs also. When I say in agentic AI, LLM can be thought of as a black box, it does not mean that any random person can then use that black box and build a robust AI system on top of it. In order to do that, you have to learn how to configure a robust operating system on top of that. Okay, now without further ado, let's start with the roadmap. The first thing I would ask you to learn is basic LLM internals. And here it might sound a little contrary because few minutes ago I asked you do not need to learn maths, you do not need to learn LLM architecture. But see, when I say basic LLM internals, I just infer basic key components like tokenizer, embeddings, logic, sampling algorithms. They are the things which will help you reason a lot in terms of the cost, in terms of the quality of output and so on. And as an engineer, you should care about these things, and that is the reason you should take a sneak peek into all these. The next thing I would like you to learn is prompt engineering. Basically, you should know what is a system prompt and how is it different than a user prompt. What are certain proven tactics like chain of thought, few shot prompting, reflection. And if I have to be very honest, learning these things is very easy, but at the same time, it is super duper hard to measure the impact that they have on your system. So whenever you make a slight code change in your prompt, whether it has led to progression or regression, is something which is very, very important. And in order to measure that, you need to know about something called as AI evals, which I will talk about later. The third thing I would want you to know about is agent memory architecture. See, these LLMs, they do not remember the past conversations that you have had with them. So you are the one responsible for building a memory architecture. Now, even in memory architecture, there are two types. You have got short-term memory, you have got long-term memory. So it's very important to distinguish between these two and learn how to build these systems on your own, or for that matter, at least understand that how they work in production. The third thing is agentic loop. Agentic loop can be learned when you first learn the idea of tool calling, and this is where it really gets very, very interesting. See, so far, your LLMs have just been a chatbot for you. They can just produce and generate a lot of text, and that's it. They cannot take actions for you. Now, whenever you want LLMs to take action, you have to really give it some sort of tool access. Just think of Claude Code. Claude Code has access to your file system so it can edit your files. It has access to Vercel APIs so it can deploy your apps on Vercel. The next thing which I want you to learn is RAG, and this is one topic which keeps on bloating month after month because there are various patterns which keeps emerging in it. Think of it in this manner. You have a secret knowledge base, some private document which you do not want to share with anyone. You do not want to share it with Anthropic or ChatGPT, so you would never want to attach the whole document in your prompt and send it right away. And even if you do that, it will cost you a lot in terms of number of tokens that you are using, and also the latency will be very high. The intelligent strategy would be to somehow extract the relevant paragraph from that knowledge base inside which the answer to a user query is buried, and just send that all the way to LLM. Building something like this where you optimize for retrieval quality in terms of metrics like precision and recall is something which is super hard and worth being learned. The next thing is MCP, which was probably the hottest topic last year. It still is, but it has a few caveats in terms of token usage and all, which I'm not going to talk about right now. But basically, MCP gives your agent strong hands and legs. What I mean by that is, it allows it to act in a much more superior way. Think of it in this manner. You want to edit a document of yours which is lying on Notion. All that you have to do is you have to connect to a Notion MCP server. That's it. Okay, if you want other AI agents to be able to talk to your organization's API to change and manipulate your data, you can even build your own MCP server and expose it. Next thing I would want you to learn about is agentic design patterns, like decomposing a task across multiple specialist agents, having a router in place which can orchestrate the job, checkpointing the task, saving the states. These might seem like jargons at this point of time, but they are very important when you build production-grade agents. The next thing, which is super important, is guardrails. Do you remember I had talked about tool calls and also MCP servers where you give hands and legs to your agents and make them capable to edit your files, hit APIs, spend money, talk to real user. But now a scary question should come to your head. LLM is a non-deterministic system. It can be tricked, it can be manipulated, and it can hallucinate. Guardrails are the safety checks which you wrap around your agent both on the way in and on the way out. On the input side, you guard against things like prompt injection, jailbreak attempts, off-topic questions, or for that matter, a user pasting their credit card number where they should not. On the output front, you check that the agent is not leaking your secret API keys or generating a toxic content or doing something like that. Let me give you a scariest example. You have to also make sure that your agent by mistake does not drop a production table. These things matter a lot in production. So having the right guardrails in place for your agent is not an optional thing. It is indispensable. The next thing is evals and observability. If you remember, I kept talking about it that whenever you make a simple prompt change, you have to measure whether you are progressing or you are regressing, because your agentic system is non-deterministic. And this is where a lot of systems fail. See, evals are nothing, they are just like a compass inside your ship. If there is compass, you know where the ship is headed. If you move off direction, the needle moves. So without evals, if you are building an AI system, let me tell you, you are just shooting blind arrows here and there, which will lead you to nowhere. And as I have already mentioned, that these LLMs are non-deterministic by nature, so you cannot simply assert the actual and expected response the way you used to do while writing unit test cases. If somebody asks an agent which teaches, let's say, science, that what is photosynthesis, the agent's answer could be different than the hard-coded answer which is written inside NCERT textbook. We cannot directly compare the two strings together. In this case, you would want to measure whether the facts are kind of matching with each other or not. For use cases like these, you would need to have some evaluators that maybe use LLMs as judge and do the right evaluation for you. Observability is twin of all these. Of course, when your agent is live, agent is nothing but a software, so when your software is live, you need to see what are the tool calls it is making, how many tokens it is using, what is the latency, what is the overall cost, and having a trace of all those things is very, very important in a production grade system. Next thing which I want you to learn is fine-tuning and distillation, and at this point you might have a lot of questions in your head. You might ask me, didn't you say that I don't need to go inside the model and tune those weights and matrices? Yes, I did say that, but when I talk about training a model from scratch, you as an engineer do not really need to learn the maths. You as an engineer just need to prepare a clean data set of examples and you can simply kick off a fine-tuning job and then evaluate the result. The real question in front of engineers is when to reach out for a fine-tuning task. Should fine-tuning be the first thing that you should do while building an AI agent? The answer is a big no. The first thing you should be doing is prompt engineering, RAG, trying out some tools, maybe doing some manipulations here and there in the code base, writing evals and then optimizing. Basically, you have to go through that tedious loop, and only when you realize that you are not able to go beyond a certain percentage of accuracy, let's say 95%, that is the time when you look up to fine-tuning. What is distillation? Distillation is simply knowledge transfer of a thin domain from a big model to a small model. And that small model could be even an open source model which you host on your own private cloud. Here, it saves you a lot of money, it saves you a lot of latency, because bigger models, they of course charge you per token, and the latency also could be very high over there because of presence of so many parameters out there. The next thing to learn is voice AI, which is pretty hot these days. See, when you learn MCP and tools, you basically learn how to configure hands and legs. When you learn voice AI, you learn how to configure ears and mouth. And that is very, very important because we as humans love to talk rather than type. Talking is faster than typing a piece of text. Now, here, the way it is done is, somebody says something and then that audio is converted into text which is fed to an LLM which again produces a text which is fed to another model which then produces speech. Okay, these days you also have speech-to-speech models. It sounds cool, right? It sounds like it's not something which is very hard because we already know the tool calling and other orchestration layers on top of it. So what's the big deal about it? The big deal about it is to make it feel real. A 3-second latency with a chatbot is tolerable, but a 3-second latency on phone with a voice AI agent is something which is deeply frustrating. This is where you have to make use of streaming of responses. This is where you also have to build a system which can recognize the voice, recognize the change. Imagine there is human on the other side who is trying to interrupt, it should be able to recognize that interruption. All these things makes voice AI an exciting field to learn and build. The final thing which I would want you to learn is image generation through AI. You might have heard of a very popular algorithm called as Stable Diffusion. Again, you do not need to know the maths behind it. You just need to know how you can use it to paint the perfect image that goes with your brand, to generate consistent piece of text with consistent font and format that you really need. So you need to engineer evals here also, with the only distinction that here the evals needs to be much more rigorous. Now, if you have heard me so far, you can recall that nowhere in this roadmap have I ever talked or even mentioned about something like LangGraph or LangChain. Not because they are not useful, they are super useful, a lot of people use them, but I have not talked about them because they are not raw skills, they are frameworks. And if you are super good with raw skills, you can master any framework at any point of time. You do not have to be slave of one framework. Because if you are good with raw skills, you know what is happening under the hood. So you can change your framework based on some measured decision. Or you can choose not to use any framework at all and go the vanilla way. See, the next decade is going to be of the people who can learn fast, who can reason deeply, who can build reliable systems, and most importantly, who can adapt continuously. These frameworks will change, models will change, APIs will change, but the ability to build robust systems, that will remain timeless. And honestly speaking, we are still incredibly early. Okay, so if you found all this useful, you can subscribe, and in the next videos, we will dive deep into many of these topics individually.